Bye-bye.
Hello, Mr. Lana, right? Okay, so we're given the integer. I want to transform that to something on the right. So basically, we extract each digit. And you see, 5, 2, 3. 5 minus 2 plus 3 equals 6. 3, 2, 1, 0. 3 minus 2 plus 1 minus 0. 1, just 1. 1, 2, 3. 1 minus 2 plus 3 equals 2.
Does it have to be minus plus minus plus?
That's right, yes. So the leftmost, we call it the most significant digit, okay? Most significant digit on the left, right? Because this is the most significant. And this one is,
Really?
this one on the right hand side,
Right.
this is 1, right? These are the least significant digit. Okay, so we start with most significant digit, always with plus 1. And the next digit is minus 1. And the next digit is plus 1 again. So alternative sign digit. Okay, so we just want to know the sum. What's your thoughts about that?
Are you given the number on the left? Yeah.
I want to get this number on the right.
You only have like one choice, like minus plus minus plus.
Yeah, one choice, yes.
Yeah. And so you're given the number on the left, and you're trying to give the number on the right.
That's right, yes.
Okay. I sort of get it.
And then, so what's your thoughts?
I think we just basically do maths.
Well done. This is what I want to hear. This is an easy question because you're saying there's only one way to doing it, right? So it's easy. It's simulation. It's basically doing what you're told, right? So you're basically doing what you're told, okay? So good. So the key point to this is that how do we extract each digit? How do we extract each digit?
So you start with the first number, which you said is the most significant digit, and then for every two digits you subtract that digit.
Subtract, and then for others you add it.
Yeah.
Okay, so my question was more like how do you get the 5? How do you get the 2? How do you get the 3? And then there are two ways, right? You can start from the left to the right, or you can start from right to the left, right? Which one is better?
From the left to the right?
I think it depends on what I think
The number is.
the like modulus, I think.
Modulus, yes, we talk about modulus. But I'm saying that, okay, so 5, 2, 3, you start from the left to the right, or you start from the right to the left. That's what I'm saying.
Left to the right?
Left to the right, and?
You said the left. I think left to right is how you do it because English you like read it like that way. But and also you said it's the most significant.
Yeah,
So I
true.
think it's left to right.
Yeah, okay, so that's what I want to know, yeah. Because 5, 2, 3, yeah, always start with the positive, right? So, intuitively, 5, 2, 3, we start from the left to the right. There are only two choices, if it's even number of digits or if it's an odd number of digits, right? You don't know which one is it. Am I right? So you can still do it from left to the right as long as we convert this into string. So with the string, then I can get each digit. We can also do it from right to the left. But the problem with the right to the left is that you don't know which one, if you 5, 2, 3, this is what? This is plus, minus, this is plus, right? But if it's 5, 2, 3, 4, this will be minus, right? Plus, minus, plus, minus. Am I right? If you start from the right to the left, you're not sure which one is the least significant digit, right? But why do we need to care about starting from the right to the left? Because it's easy to do the math, modulus. Right, look. 5, 2, 3, 4. How do we get the 4? Modulus by 10. Modulus by 10. And then divided by 10. How do we get the 3? Modulus by 10. Divided by 10. Modulus by 10. Divided by 10. Let's do this, the first approach using the converting to the string. S equal if the number is defined, okay, Fn, okay? And then this needs to return integer type. S equals str, we convert it to a string. Answer equals at the beginning 记得 sign plus 1 minus 1, right? So at the beginning is plus 1.
Yeah.
For I in S, answer plus equal. Answer plus equal. I, this is the string. We convert it to integer. Convert it to integer.
Yeah.
Times
Yeah.
sign.
Yeah.
Okay?
Yeah.
And then I need to make plus 1 to minus 1. How do I neglect the sign? Plus make it minus. If it's minus, I want to make it plus. How do I do this? Sine equals what?
Equals minus.
Minus sine. Good job. Or sine, another way, sine equals, sine times equal minus 1. 1 times minus 1 is minus 1. And minus 1 times minus 1 is 1. And then return answer. Look, if the number n has n digit, the time complexity, we're going through each one, so On. Space complexity, we need to convert it to a string, and this is On, right? If n is the number of digits, okay, number of digit.
Yeah.
So n is the number of digit, then it's log 10 base n, right? Look, because log 1, 2, 3, 4, how many digits? 4 digits. So 1, 2, 3, 4 is the inner scale of log 10, 1, 2, 3, 4, okay?
Yeah.
N is the number of digits, and log 10 base 10. Log 10, 100. What's this number? 10 to the what power equals 100?
2.
2. Log 10, 100 equals 2. Okay? Make sense?
Yeah.
Okay. The other way, we're going through the number from the right to the left. Okay? Okay, so there's a trick to do this. There's a trick we do this. Okay? Previously, I was talking about that we are not sure the least significant digit, if it's the plus or minus, right?
Yeah.
Yeah?
Yeah.
Okay, how about let's try with minus 1. 1, 2, 3, 4, okay? Yeah. Minus 4, plus 3, minus 2, plus 1. And if I add another digit, minus 5, plus 4, minus 3, plus 2, minus 1. Minus 1, plus 1, minus 1, plus 1. So plus 1 and the last one. Minus 1, plus 1, minus 1, plus 1, minus 1. This is 1, 2, 3, 4, yeah? The answer should be 1 minus 2 plus 3 minus 4. This is equals to minus 2. Okay, this is the answer. This is correct. And the sign is plus 1. 1 minus 2, okay, I'm confused.
1 minus 2 plus 3 plus
2
4.
2 add 5.
1, 2, 3, 4, 5, 6,
Is it
7,
7?
7, yeah? Minus 1, 2,
7.
minus 2. Is this 7? Why is this 7?
100!
This is 1. This is 1. 1. So this is 3, okay? And now what do we get from here?
7.
Minus 1, minus 1, minus 3, plus 2, minus 1. That's minus 4, minus 2, minus 3, okay? Okay, so look, if we are always starting with the minus 1 on the least significant digit, for the odd number of digit number, we need to negate this, right? So, but it's okay because at the end, the sign is minus 1. We just need to fix the sign by times the sign, okay? Does it make sense?
Yeah.
Okay, let me repeat, okay? This is a little bit tricky. Let's have a little strategy, okay? Let's start with minus 1 from the right to the left. So this equals to minus 2 plus 1, okay? This is minus 1. If we have another value with the 3 digit, 1, 2, 3. This is minus 3 plus 2 minus 1. This is minus 2. Okay? But the answer for this one should be 1 minus 2 plus 3. This should be 2. Alright? But we get minus 2. But that's okay. We want to change it minus 2 to 2. We just need to fix the sign by times the sign. Sign, look, minus 1 plus 1 minus 1 times sign, then you return this. Okay? And how about this one? Minus 1 plus 1. We still need to fix the sign, but it's okay because minus 1 times 1 equals 1. So we times sign. Okay? So the strategy is that we start from the least significant digit from right to the left, and we keep tracking of the sign. Sign start with minus 1 plus 1 minus 1 plus 1. And at the end, we just have to fix the sign by multiplying the answer to the sign. Does it make sense?
Yeah.
We can do this from right to the left, okay? F and n is a digit. It needs to return an integer. Answer equals 0. Sign at the beginning we set it to 1, but we immediately times it to minus 1. While n is bigger than 0, answer plus equal sign. Okay, I need to change the sign. Sign equals minus sign, right? At the beginning is 1, and we are starting from right to the left, it immediately become minus 1, okay? Sign times n I want to get this n number 1, 2, 3. I want to get this 3. How do we get it?
Modulus.
Modulus 10. And then we need to get rid of 3. How do we get rid of 3?
Shift. No, I mean, divide by 10.
Divided by 10. And then, okay, now we get this. Now this answer, we need to return answer times sign, right? Okay? This is the last step to fix the sign, okay? This is from right to the left.
Yeah.
Time complexity.
O. N.
Space complexity first.
1.
O1. Okay, O1 because there's no arrays, we're given n, we just have a few variables. O1. The time complexity,
It's hard.
it's not. So what are we doing with this n? Look, 1, 2, 3, 4, 5.
N?
What's n? Look, we just get rid of this digit, get rid of this digit, get rid of digit. There are n digit, right? So it's O(n). Easy, simple. The same as
You
the
said
first one.
O(n).
But you need to tell me what's n.
We did.
And it's
Usually, it said it's O1. When you say O1, you don't need to say n because there's no n. But when you say On, you need to tell me what n is. N could be anything.
N is N.
Okay,
N.
and n is the number of digit in decimal format of this number. For example, 1, 2, 3, 4, then n is 4. Because what are we doing here is get the least significant digit, get rid of
But
it.
you don't need to explain because all you need to know is O(n).
No, use On. When you say On, it's just 50%. When I ask you what's the time complexity, you say On. But I don't know what n is. You need to tell me what n is. N is the number of digits.
I think you know what n is because you wrote it.
No, n could be anything. Okay. Okay. This is On. N is the number of digits, right? Okay. So
You said it is the number of digits.
yes, I will just say okay. Divided by 10, okay.
Then you need to convert it to integer.
We don't convert it to string. This is all mathematics, right? All numbers, numbers. We get the digit by modulus, so it's all numbers. The thing here is we need to multiply the sign. As I said, this is a tricky way from right to the left. But from the left to the right, we can convert it to a string and get each digit, right? And then we convert it to a string and then we need to convert it back using the int I. Block 2 is usually for binary. 15 in binary is 1111, right? You know that, right? And if we want to go through the digit in binary format, it's 1111. And the time complexity usually in this case is log n.
N.
Log base 2, n is the number, is 15. Log base n, now this is 4. In binary is 1111, okay? Every time we get 1, we shift it. Make sense?
Yeah.
What have you learned today?
Numbers, and we're doing some
Stuff.
sums. So we're like plus minus until on all of the digits, and then we're getting the sum.
We're done. And then how can we do it usually? How many ways we learned how to do it today?
2.
What are those?
From left to right and right to left.
Yeah.
And which one you think is better?
Left
Left
to
to
right.
It's easy to implement, but which one is more efficient in terms of
Right to
space?
left. Right to left.
Why?
Because if we were correct, you wouldn't have said that.
Okay, so what's the space complexity for the left to the right?
Oh.
We need to convert it to string, so on. What's the space? N is the number of digit. Okay, what's the space complexity for right to the left?
O(1).
1.
So which one is better?
Right to left.
Because O1 is better than On, right? Both time complexity is On. The N is the number of digit in the decimal format of N. Okay, that's it for today. Bye bye.
Good. Hello.
Bye bye.